What if a visitor from another star system showed up and broke every law of physics we thought we knew? On October 29, 2025, that's exactly what happened. The third confirmed interstellar object, 3I Atlas, went completely wild as it rounded the sun, erupting in a way no scientist could explain. It was a cosmic anomaly that challenged our most fundamental models of the universe, forcing a complete rethink of what's possible out in the cosmos. What really happened out there in the sun's glare, and what does it tell us about the mysteries lurking between the stars? Let's delve into it. The alarm. How does a cosmic emergency begin? Not with a bang, but with a spike in the data. On the night of October 28, 2025, astrophysicist Carl Battams at the Naval Research Lab was monitoring the feed from the STEREO-A solar observatory when he saw something impossible. The numbers from 3I Atlas had jumped off the chart. Its brightness was suddenly surging, far beyond what any model predicted. At 0126 UTC, he flagged the anomaly in his team's chat channel. The alert was out. 20 minutes later, halfway across the world, astronomer Ye Quanji at Caltech independently confirmed the break using data from the SOHO Space Telescope. The two analysts quickly agreed. Something deep inside this interstellar visitor had fundamentally changed. This wasn't a slow, gradual brightening. It was an abrupt, violent trigger event, unlike anything they had ever recorded from a comet. The initial alarm sounded by Battams wasn't just a note about a curious object. It was the start of a global scientific fire drill, a race to understand an object that was actively rewriting the rules in real time. Breaking models. Imagine you have a rule book for how comets are supposed to behave, and an object from another star system shows up and sets that book on fire. That was 3I Atlas. As analysts like Ye Quanji looked closer, the data became even more bizarre. The comet's light curve, which tracks its brightness, was steepening at an insane rate, described by the formula R to the -7.5 power. In layman's terms, this means its brightness was increasing exponentially faster than the physics of sublimating ice should allow. It was steeper than any comet from our own Oort cloud, and the rate at which its brightness was doubling was completely unheard of for an object so close to the sun. This violent surge in luminosity defied the basic laws of thermodynamics that govern comets. Every known model for cometary behavior was useless here. They all predicted a smooth, steady ramp-up, not this sudden explosion of light. The global network of astronomers combing through the raw data was stumped, forcing them to question every assumption. The sharp, unexpected break from all predictions was a clear signal that they were dealing with a completely new class of object. Chemical clues. When an object starts acting this strangely, the first question you ask is, what is it made of? As the brightness spike unfolded, spectrographs got to work, translating the raw light from 3I Atlas into chemical fingerprints. The initial results revealed some classic cometary ingredients. They saw strong C2 swan bands, which glow with an unmistakable blue-green signature, and emissions from NH2, a fragment of ammonia. Both are signs of volatile ices turning directly into gas as they are heated, a process called sublimation. This told astronomers that, at its core, Atlas was venting gases like a typical comet. However, the sheer intensity was anything but typical. These were not subtle features. They were screaming out from the spectra. The presence of these molecules hinted at a rich cocktail of ices that had been locked away for billions of years. But as veteran cometary scientists like David Jewett reviewed the data, the simple presence of these chemicals wasn't enough to explain the scale of the event. The real mystery lay in what was driving this massive, unprecedented release, suggesting a deeper, more explosive mechanism than simple surface heating. Ultraviolet surge. The most critical evidence in this cosmic investigation came from a part of the light spectrum we can't see, the ultraviolet. With 3I Atlas lost to ground-based telescopes in the sun's glare, astronomers turned to the Swift satellite's UV optical telescope. Its detectors picked up a massive surge of OH emission, which are hydroxyl radicals. In comet science, OH is the unmistakable smoking gun for water. It forms when the sun's powerful ultraviolet light splits H2O molecules that are escaping the comet's nucleus. The data from Swift was precise and, honestly, kind of shocking. As analyzed by planetary scientists like Casey Leese, it showed water production rates soaring to about 5.7 times 10 to the 28th molecules per second. That figure is nearly 40 times higher than the water output measured just 1 month earlier. a truly colossal eruption of vapor. The timing was perfect. This huge surge in water production tracked exactly with the sudden brightening of the comet. This confirmed the outburst was a deep-seated violent eruption driven by the sublimation of vast amounts of water ice, not just a superficial dust event.
Space eyes.
With 3I Atlas too close to the Sun for telescopes on Earth to see, humanity's only eyes on the event were our space-based solar observatories. The STEREO-A, SOHO, and GOES-19 spacecraft provided the only direct views, and honestly, the images they sent back were just as confusing as the data. A comet this bright, erupting this violently, should have produced a spectacular dust tail. Instead, the images revealed a large, elongated coma, about 4 arc-minutes across, glowing brightly against the solar glare. But the classic fan-shaped plume of dust was completely and utterly absent. The coma's shape was smooth, almost featureless, lacking any of the jets, fans, or anti-sunward structures that normally appear. Analysts, like Matthew Knight, poring over the pixel-level details, could find no sign of the dust that should have been there. It was a ghost, all gas, no solids. This visual paradox was a profound puzzle for the imaging analysts, who were witnessing a powerful comet break the fundamental rules of outbursts right before their eyes.
Missing dust.
Why was the dust missing? This became the central, haunting question for everyone studying 3I Atlas. In our solar system, the physics are simple. When volatile ices like water turn to gas and erupt from a comet's nucleus, that escaping gas drags dust and rock along with it, creating the iconic tail. A spike in gas almost always means a spike in dust, yet Atlas was venting colossal amounts of gas directly into space, with little to no solid material joining the outflow. Seasoned observers were baffled. They searched the data for any hint of dust, faint jets, a subtle broadening in the red channels, but nothing materialized. This absence wasn't just a visual curiosity, it threw a wrench into every attempt to model the comet's physical behavior. Without a dust tail, crucial estimates of the nucleus's rotation and surface structure became pure guesswork. This strange behavior suggested something profound about its composition. Perhaps its dust grains were too large and heavy for the gas to lift, or maybe the gas was escaping in a diffuse way that couldn't loft any solids at all.
JWST's discovery.
Just when the mystery seemed impenetrable, the James Webb Space Telescope delivered a breakthrough. In July 2025, before the comet got too close to the Sun, a team led by NASA's Dr. Stephanie Millam, who's an expert in cometary chemistry, had secured a set of spectra that would completely reframe the puzzle. The JWST's near-infrared spectrograph didn't just look at the gas, it peered at the very architecture of the comet's nucleus. The data revealed that the surface of 3I Atlas was anything but pristine. Instead, it was covered by a thick crust, about 15 to 20 meters deep. The spectra also showed a shocking chemical ratio. The amount of carbon dioxide compared to water soared to nearly 8-to-1, which is, honestly, far beyond anything seen in our local comets. This was the smoking gun. Dr. Millam and her team realized they were looking at the direct chemical consequences of a long, harsh journey through the interstellar medium. The unique infrared capabilities of JWST allowed them to see these chemical fingerprints with a clarity that was previously impossible.
Cosmic armor.
What could build a 20-meter thick crust on a comet? The answer isn't a star, but actually, the galaxy itself. Dr. Stephanie Millam's team concluded that the crust on 3I Atlas was forged by billions of years of bombardment by galactic cosmic rays during its journey between the stars. These are high-energy particles that relentlessly slam into any object in deep space, fundamentally altering its chemistry. This intense radiation converts simple ices into complex organic molecules, creating a tough, dark, and compacted surface layer. This isn't just a surface tan, it's a deep protective armor. This radiation-processed mantle acts as both a shield and a filter, slowing the escape of gas from the interior. The pristine, volatile ices were still there, but they were buried deep beneath this cosmic shell. The theory is that the sun's heat slowly penetrated this armor, eventually reaching the untouched ices below and triggering a runaway explosive reaction. The surface of Atlas wasn't a window into its birth, but a detailed record of the brutal journey it had endured.
Rival theories.
With so much conflicting data, the scientific community split into factions, each with its own theory to explain Atlas's bizarre behavior. One idea was the carbon dioxide cooling cap model. It argued that a CO2 frost layer insulated the comet until the sun's heat blasted it away, triggering the outburst. A different, more speculative camp proposed an exotic or engineered nucleus. This scenario suggested the activity would switch on abruptly once a certain threshold was crossed, hinting at a non-natural structure, though, honestly, no non-natural signals were ever detected. Then there was the model supported by the JWST data, the radiation-processed crust. This theory, championed by researchers like Suzanne Falzner, suggested the cosmic armor delayed activity until deep heating caused a catastrophic failure of the crust. This model best explained both the lack of dust and the sudden violent release of gas from deep within. Each model made clear, testable predictions, but with the comet fading, the debate remained unsettled, a clash of ideas at the frontier of science.
Global sprint.
The bizarre behavior of 3I Atlas created a rare moment of unity and urgency. With the comet diverging so sharply from all known models, astronomers knew that no single team could solve this alone. As Atlas began to move away from the Sun in November 2025, a fleeting window of just a few weeks opened for Earth-based telescopes to observe it again. This triggered an unprecedented global observation sprint. In online forums, astronomers like Carl Battams and Ye Kwanzi pressed space agencies to release all raw data from STEREO-A, SOHO, and JWST immediately. In response, teams around the world coordinated target lists, shared calibration scripts, and posted raw files to public repositories. Radio astronomers listened for non-natural signals, while spectrographers focused on catching any changes in the comet's chemistry as deeper layers were exposed. This collaborative effort was a new model for astronomical discovery, allowing the entire world's scientific community to work together to solve a shared cosmic puzzle. On October 29, 2025, 3I Atlas reached perihelion and put on a show that defied all explanation. It brightened at twice the predicted speed, its water vapor outflow jumped by a factor of 40, and it did all of this without producing the expected dust tail. The JWST revealed a deep, radiation-hardened crust, offering a tantalizing clue, but the ultimate cause of the outburst remains unresolved. Competing theories exist, but there is no consensus. With the comet already fading back into the interstellar dark, the true nature of 3I Atlas is still an open question, a powerful reminder that the universe is far stranger than we can imagine. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos. What do you think is the real story behind this interstellar visitor? Thanks for watching Future Facts.